Hey guys, Mr. Herring here. Believe it or not, this is like take 5 of my video I'm trying to create for you so I could just sample some problems, um, show you how to do them that should help you before you try to conquer these IXLs on your own. You know, it does give you a great explanation, shows you how to do it if you get them wrong, so really pay attention to that. But I'll go ahead and I'll show you some things and tell you some things to think about while you do these. Hopefully it'll help you. All right, here we go. So looking at the adding and subtracting word problems,
Have you already ordered the frames?
Connor, I'm doing my video. On a hot day, Patrick poured 2 1/6 buckets of water into a plastic pool. A few minutes later, he added 5 1/6. He added another 5 1/6 buckets. How much water did Patrick pour into the pool? Well, the first thing we're doing is looking for key words. What's the key words in the story problem that's telling me whether I'm adding or subtracting? Well, when it says he added another, that's a pretty big key that or clue that we're going to be adding these. So let's go ahead and set it up. And I set them up vertically here. So I would have the 2 1/6. 2 1/6 plus the 5 1/6. Yep, and this one's pretty easy because it's got a common denominator already. So we could already set it up to add. That common denominator of 6 is going to stay on bottom. We just add the 2 numerators, which is 1 plus 1. That gives me 2. And then just add the whole numbers after that. So total in the pool, it'd be 7 2/6 buckets of water. Now, we got to simplify our fractions, though. So keep 7 whole the same. And just think about dividing a common factor that goes into 2 and 6. A number that's evenly divisible into 2 and 6, and that would just be 2. 2 is the only number that goes into 2 besides 1, and that wouldn't help us. So we divide them both by 2. So 2 divided by 2 is 1. 6 divided by that 2 is 3. And that's it. I should have 7 1/3. Let's check it out. All right. Conquered. Next set. Cassie has a pink extension cord that is 4 5/6 feet long and a blue extension cord that's 3 feet long. If Cassie plugs one extension cord into another, how far will the cords reach? So what are we doing here? Adding or subtracting? We're combining 2 cords, okay? It says that she has another and she is going to plug one into it. So we're combining the 2. So let's set these up to add. All right. So the first number we got is the 4 5/6. We're adding 3 to that. This might be the easiest problem you have in the whole set. When you add, well, the fractions, there's nothing to add to 5/6. So you just keep that fraction the same. You're adding 4 plus 3. So combined, it'd be 7 5/6 feet long. Okay, 7 5/6. Let's hopefully get some tougher ones coming up here. Okay, so Jeanette went to the salon and had 4 3/10 inches of hair cut off. The next day, she went back and asked for another 1 inch to be cut off. How much did she have cut off in all? Again, you know, we're combining the total amount of hair that was cut off. So we're adding these 2. If you're going to add, this doesn't take much to set up and do. It's a mental problem, really. But all you have is the 4 3/10 inches. And she's going to add 1 more inch cut off. So the clue, you know, at the end when it said how much will be cut off in all, that's kind of another clue that you're going to be adding these 2. So there's not much to that, right? You keep the fraction the same because there's nothing to add to the fraction part, and 4 plus 1 is 5. Come on, give us some tougher ones. Oh, that's yeah, I had the correct answer. I just put an O instead of a 0 there. All right. Moving on anyways. Okay, a couple more. Carter drew a purple line that was 7 1/6 inches long. Then he drew a yellow line that was 5/6 inches long. How much longer was the purple line than the yellow one? So how much longer, how much bigger, okay, how much shorter, all that stuff means to subtract. How much faster. You're comparing two things with subtraction. So let's set it up where you got the big number on top here. So it's 7 1/6 minus the 5/6. This is actually a good problem here because we're going to have to do a couple things. We're going to have to borrow here first of all. I cannot take 5 out of 1. So I have to borrow from this 7. What I really want to borrow, you can only borrow 1 from the 7. But when we borrow 1, we don't want to borrow 1 in the form of just 1 whole. We want to rewrite that 1 as a fraction that I could add to this fraction easily. So that fraction would want to have the same denominator. So the fraction that's equal to 1 whole with this denominator of 6 would be 6/6, right? 6 out of 6 is the whole thing. So I'm going to add 6 out of 6. I'm going to add 6/6 to 1/6. I'm borrowing from this 7. So that 7 now becomes a 6. And I'm adding 6/6 to 1/6. So when you add 6/6 to 1/6, you get 7/6. Okay? Now we could just subtract 7/6 minus 5/6. We got our 6 denominator on bottom. And then we got 7 minus 5, which is 2. And then 6 whole is left. Got to simplify. You're going to have 6 and divide by a common factor of 2 again. Because they're both even, you could always divide by 2 if they're even until you can't divide by 2 anymore. So 2 divided by 2 is 1. 6 divided by 2 is 3. Nailed it. All right, that should be it. Let's go. 6 1/3. All right. Okay, look at this one. I'll do maybe just 2 more like this, or I'll make one up on the end. Yesterday, Melly had, there's no L in her name, it's just me, had 12 pounds of granola in the pantry. This morning, she and her family ate 7 1/10 pounds of granola for breakfast. How much granola is left? Ooh, good one. Okay. So let's start again. How much is left over? That's your key. Keywords we're subtracting here. So we're starting with 12 pounds. Then the 8, 7 1/10 out of the pantry. We're trying to find out what's left. Well, I can't subtract this fraction from nothing. I have to rewrite this 12 number with a fraction. So the way to do that is the same kind of thing we just did. We're going to borrow 1 from the 12 to make it 11, but we're not going to write 1 over here. We have to write a fraction over here that's equal to 1. And we want that fraction to have the same denominator as this fraction so we could subtract easy. So it would be 10/10. 10/10 has the same thing. 10/10 is the same thing as 1. And it's got that common denominator that I want now. So I could subtract. 10 is going to stay consistent on bottom as my common denominator. 10 minus 1 is 9. And then I just got to do 11 minus the 7, which is 4. That's it. So that one should be 4 9/10. One final problem, because they didn't give you a lot with different denominators. We'll do one last one here. So let's say we've got 8 3/4. We're going to subtract from that 6 7/8. So if we're subtracting these two, I got to get that common denominator first. That's what I don't have this time. So let's just rewrite these. I'm going to rewrite these problems over here. I've got 8 still, I've got 6 still as my whole numbers. But for my fractions, we're going to use that common denominator of 8. The reason we're going to use 8 is because it is the least common multiple of 4 and 8. We're thinking of a number that both of these denominators, 4 and 8, are a multiple of. So if you count up by 4s, 4, 8, 8's a multiple of 4, and 8 is obviously a multiple of 8. So this is your least common multiple. So we're going to have 8 and 8 is tone in the background. If it did, no big deal. So that's my common denominator. So then this fraction stays the same. I didn't change that one. But this time, to make 4, 8, to turn it into 8, I had to multiply 4 times 2 to get 8 on the bottom. So you got to do the same to the top. We're rewriting this as an equivalent fraction. So 3 times 2 is 6, right? 3/4 is equivalent to 6/8. Just multiplied it by 2. Now I got a common denominator. So if I'm subtracting, I still can't take 7 out of 6. So I have to borrow again. So I'm going to drop this 8 down to a 7. And when I borrow 1, I'm not going to just add 1 here. Instead of 1, I'm going to make an equivalent. I'm going to make a fraction that's worth 1. It also has to have the same denominator of 8, remember? So let's have it be 8 over 8. 8 over 8 is the same thing as 1, and I could add 8 eighths to 6/8, and that would give me 14 eighths. So now that's what I have on top. I've really got 7 and 14 eighths on top. All right, so when I subtract here, 14 minus 7 is 7. 8's on bottom. And I got the 7 that I had to drop 8 down. I had to take away 1 from the 8 so I could do that borrowing. So I left with 7 minus 6 is 1. And that would be the answer for that problem. Okay. Good luck, guys. Let me know if you guys have any other problems or issues. I'll do my best to practice some problems online and share all the help videos that I can. All right. Take care. Miss you guys.